Okay, good afternoon, everyone. So today we're going to talk about some applications of the inverse matrix. In the previous lesson, we learned that inverse matrix is a special type of matrix that if we sort of multiply the matrix by its inverse matrix, we'll get an identity matrix, which is sort of like the ones in our daily calculation. So in other words, the inverse matrix is like the reciprocal of the matrix. Now, at this stage, because you're just in year 11, the only way to find the inverse matrix is to use your CAS calculator. All what you need to do is to type in that matrix with all the number listed, and then use the power and then input -1 as the power. And basically, the CAS calculator is going to tell you the inverse matrix. Now, you'll be working on finding the inverse matrix of 2 by 2 in later in year 12, but definitely not now. Okay, so when we're looking at inverse matrix, you might be thinking, why do I need that and then how do I use it? Okay, so here is a very important application of the inverse matrix. We can use the inverse matrix to solve the simultaneous equations. How do I do that? Okay, so we can sort of write the matrices, okay, based on the information provided. Let's look at this simultaneous equation, okay? It means we have more than one equation at the same time. We get 2x plus 3y equal to 6 and x plus y equal to 2. Now notice this is already organized for you. So all the x and y's are arranged on the left-hand side and all the constants or the numbers are arranged on the right-hand side. So we can sort of write this in the matrix format. So if we bring each number to its corresponding position, so the first number I have, because I have 2x, then I just put in the number 2 here, okay? There's no need to write x. And I put number 3 here. And then when we have x, that means we have 1x, so we just put 1 here. And then y, the same idea, we just put 1 here. So 2, 3, 1, 1. These are the coefficients for x and y's. Now, on the right-hand side, I have this one called 6 and 2. It's quite self-explanatory. We have 6 and we have 2. So we can write a matrix 6 and 2. So we got two matrix. Okay, so we got two matrix. The left-hand side, we got the constant. Sorry, coefficient. So it means the number before x or y. And on right hand side, I have the matrix for the constant. Okay, so with these two matrices, I will be able to apply a very interesting trick to solve this simultaneous equation, means to find the value for x and y. How do I do that? I will need to use the idea of inverse matrix. We will need to inverse the first one. So we have 2, 3, 1, 1. We write this matrix again. 2, 3, 1, and 1. Now, instead of doing that, I can do the inverse. And then I multiply it by this matrix 6 and 2. Okay? So notice I use the inverse here. It's very important to use the inverse. And I should be able to get an output. Okay, so let's use the CAS calculator to help us to find this one. So, CAS, let's start a new document. Don't want to save anything. Okay, so add a calculator. Remember when we are doing the matrix, we gotta add in the matrix in the button over here. We have a 2 by 2 matrix, change numbers, and then we have 2, 3, 1, and 1. Okay, so and then we use the power button to put in the -1 as inverse, and we multiply that by another matrix. We got to type in again. It's 2 by 1. So the matrix says 6 and 2. These are the two numbers. Now, when I press enter for that, I'll get the result which says 0 and 2. So we can just bring it there. Okay, 0 and 2. The upper number will be the value for x, and the lower number will be the value for y. And this is going to be the solution to this equation. Okay, let's just have a check. So when x is 0 and y is 2, we bring this so into the first equation up here. So 2 times 0 plus 3 times 2 will equal 0 here. Okay, so that's so the left hand side 2x plus 3y will equal to the right hand side, which is the 6 of it. So the first equation is true. Now the second equation x plus, so that will be 0 plus 2. Okay, give us just 2. So it is also equal to the number here. So therefore the second equation is also valid. So in another word, 0 and 2, these are the solution to this simultaneous equation. And this is the only pair of x and y value that will make it work. It's pretty interesting, isn't it? So we didn't do much. But we just need to find a matrix, inverse it, and multiply two things together. Let's go through this again. So we need to write the first matrix. We call that matrix A for reference. Our matrix A is going to be focusing on the coefficient. So the coefficient means the number before x and y. If there's no number, that means it's 1. Okay? So we write 2, 3, and 1, and 1. That's our matrix A. And then we also need to have a matrix B. We're talking about the constant. The constant means all the numbers on the right-hand side of the equation. So the numbers. So the matrix B will be equal to 6 and 2. Okay? So let's just put A and B at the bottom for reference. Okay, so when we are trying to find the result, we just use the inverse. Remember, it's very important to put that inverse there. So put the inverse of A and then multiply it by the second matrix, matrix B. And the result is going to be the solution to this simultaneous equation. It's pretty magical. We'll leave the reason to the last page if you are interested. But so far, we just want to focus on the applications to how to use that. Okay, so now, of course, you may be able to solve like x and y, and you're also going to use this to solve a much more complicated question. So for example, if we have x, y, and z, three variables, three equations, and then we can also solve using the very same idea. How do we do that? First, write down the equation using all the coefficients. Okay, so the coefficients are all here, the number before x and y and z. So it will be 2, 3, and -1. So check the negative sign. And it will be 1, 2, and 1, and 3, and -1, and 1. So this is our first matrix. This matrix tells me the information about these equations. Okay? And the second matrix will be 5, 8, and 4. You don't need to change any order. You don't need to change anything, in fact. Just bring all the numbers into the matrix. Okay? And then remember, we will need to inverse the first one and multiply the second one. The rest is on the CAS calculator. So all which we need to do is to bring out our CAS calculator and try to type the 3 by 3 matrix. It's a bit big. Sorry, my memory is failing me, so I have to keep switching. 2, 3, and -1. Okay, we also have 1, 2, and 1. Last line says 3, -1, and -1. The first matrix is done. Okay, and I use the power button and then type in -1. Okay, so that's the first matrix done. I will need to multiply the second matrix. The second matrix is sort of like 3 by 1 matrix. There's only one column, and it has the value 5, 8, and 4. So we just put 5, 8, and 4. Press enter. Okay, fair enough. Did I make any mistake? Yes, I did. So sorry. That's totally my bad. The reason why it's messy is because I put in the wrong number on the bottom column. So mistakes are normal. As long as you realize it's a bit weird and try to double check and you're more likely to find it. Okay, so if we press enter, nice looking integers. I mean, not always having the integer solution, but many questions are well designed. So if you have a whole number is more likely to be the answer. Doesn't mean this is wrong, it just means double check. Okay, so our result for that is a typical matrix says 1, 2, and 3. Sorry, Indigo, I reply to your message later. Okay, so it'll be 1, 2, and 3. What does that tell me? Okay, that tells me that the solution for this equation is x equal to the first number 1, y equal to the second number 2, and z equal to the third number 3. Of course, depending on which number I have in that particular matrix, I have slightly different values for x and y and z, but the first number is for x, the second number is for y, and the last number is for z. It's pretty magical. You can check the results by substituting that back into the equation. And surprisingly, you should find every single line works. Every single line is true. So this is a very, very important application of this matrix and the inverse matrix in particular. Now we're going to look at one last example. And in this example, things are getting a bit more trickier. Why is that the case? Because in the previous examples, I have x, y, z all on one side, but this one, we have x and y on different sides. So we need to first rearrange the equations to make sure that x and y are on the same side. So we need to bring the x to the left-hand side of the equation. And when we do that, don't forget to change the sign. So 3x becomes minus 3x and plus y. Okay, and on the right hand side, I'll remove this bit, so the only thing left will be a positive 6, so I can write 6 here. Now, the same way, if I move the negative x to the left hand side, I have a positive x, okay? Because the negative of the negative makes a positive. And plus y is going to be equal to 2. Now, from that point onward, life is easy. We have the matrix, we just need to put in all the numbers. Negative 3, 1, 1, 1 is going to be having the solution, which is 6 and 2. And then we just need to inverse the first one, multiply the second one. And the rest is the job on your CAS calculator. Oops, did I do anything wrong? So the CAS calculator goes in here. So still the same way, putting a 2 by 2 matrix, a 2 by 2 matrix, and the numbers are negative 3, 1, 1, and 1. Okay, and then we inverse that. Now always remember inverse it, and then we multiply it by a new matrix. Matrix is 2 by 1. So we have 6 and 2. So 6 and 2. Press enter. They got negative 1 and 3. Okay, so that means it's equal to negative 1 and 3. Okay, using this information, I'll be able to say, therefore, the solution for that is x equal to the first number, negative 1, and y equal to the second number, 3. Okay, so this is pretty much how we apply and how we use this inverse matrix. I'm going to generally also talk about why is this the case and why is this true. Okay, so that's the challenging bit. I'll leave that as a blank page. Okay, so why do we use that? How do we know that it is the case? So for example, if we have a 2x plus y and x plus y and the first one equal to 3, second one equal to 2, make our life a bit easier. Okay, so when we write this matrix, we can sort of say it's just like 2, 1, 1, 1. Okay, now if we use this matrix to multiply, now this time I want to use the original matrix to multiply x and y. Okay, think about it. We would get a very interesting result. We will get 2x plus y and x plus y.